Okay, welcome back. So I filled out the table with all the selections using this same M1 V1 calculation for all the combinations of these flasks and pipette volumes. Okay? So I want to point out a couple things. One is that we only need 5 solutions, okay? And obviously here there's 16 different selections, so we're not going to use all of these, okay? The other thing that you'll notice is that there's patterns here, right? If I make a 1 to 100 dilution of 601.2, I end up with 6.012. And even if you round these to the nearest integer, you could see that, well, if I double the volume, I'm going to double the concentration, which is going to give me a concentration of 12. And my highest solution should have a concentration of 10. So if I was thinking about what I was doing, I wouldn't have made these calculations because they're unnecessary, right? So the other thing we're going to want to do is pick solutions that are spaced out, right? So the lowest concentration that's between 1 and 10 would be 1.204, 2024, okay? And then we can kind of go up the line, right? The 3.6072 looks good, the 4.8096 looks good, the 7.2144 looks good, but you'll notice that that's the highest concentration we have. So that would leave us with a curve where we'd have points here, 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 right? But we wouldn't have a point close to the end, okay? And so it's worth thinking about, well, why does that even matter? Why do we want to have a point close to the end? Well, as you remember from lecture, the data that you get for your unknown solutions is only valid if it's within the range of your calibration curve, okay? So if that calibration curve is in a relatively narrow window, then you have a relatively narrow range of concentrations that you'll be able to calculate with analytical validity from your unknown solutions. So we really want to have a fifth data point over here, okay? And so that's why I wanted to use, so that's why I indicated that you could use here a solution that's prepped from 4 milliliters of a volumetric pipette. Now you don't have a 4 milliliter pipette. So what you can do is you can use 2 aliquots of your 2 milliliter pipette to get that concentration, okay? And you can see that if we did that, I'll just use my handy calculator here. If we used 4 milliliters of this 601.2 ppm solution and diluted it to 250, we'd get a concentration of 9.6192, which is pretty close to 10. And so that's the 5th solution that I would end up making. Okay. The couple other important points, when you're making these solutions, you want to make sure to use the volumetric glassware, pipettes and flasks, obviously. You want to make sure that those are really well rinsed with deionized water so that you don't have contamination, and it's really important that you rinse them between solutions that you're making. If you make your highest concentration solution first, then you have potential to concentrate your lower concentration calibration standards. The other thing that's important to remember is that we have 4 significant figures here, and so we want to keep a lot of significant figures in these calculations, right? So you don't want to round off to the tens place or the hundreds place. And then the last thing, and this is something that I tell my students, my research students, and you guys in CHEM31, is that the most important thing is that you record exactly what you did. Because a lot of times if you make a mistake, we can go back and figure out where that point really should be. If this number really should be 5.9, right, then we can move this point a little bit if we need to, and that's the correct concentration. But it's really important that we know exactly what you did in order to do that. So in the next video, I'll talk about making the magnesium calibration standards.